All right, one of these clocks says 9 o'clock, so I'm gonna get away out of that one. Couple quick announcements this morning. The 8 is live to sign up for. So that is something that if you are taking this class and have not passed the 8 and are considering or are enrolled in a major that has courses that require the 8, you should go do that. Even if right now you do not feel 100% prepared, the goal will be to have you 100% prepared in the next few weeks. And you get 3 attempts before we sit down and talk to you. So I highly recommend this being one of those attempts. If no other information, let's say it doesn't work out well, it's information for you. It helps you to know, here's where I am, here's where I need to be, and you can start yourself on that path so that you maximize your chances next quarter. But my goal is for as many people as possible to pass this quarter. And I'm tailoring all of this content to be useful to that end. So even if you don't feel 100% yet, sign up for it and we'll get you as close to that as we can over the next few weeks. Second, as part of that preparation, feel free to come to my office with any questions about anything on the 8th. I ordered an 8-ball last week. This is what faculty funds are for. Not very many of them, but not very much of them, but I did order it in. I'm going to put some tape over the 8 and it's going to be the 8-ball. You can come ask it questions about the 8 in my office and it will give you random answers that have nothing to do with your skill level. Very useful, very fun. Goes well with my dad joke calendar, my cat butt magnets, and other weird things that you can find in my office. Okay. Questions before we get started? I guess there is one more announcement, and that is Friday of this week, I will be releasing a study guide for our first exam that will take place a week from Friday. My usual plan with exams is study guide a week before the exam. The day before the exam will be a study period where I will bring no content to class and I will rely on people's questions to make that content. So just be aware that it's a very long, boring class of us staring at each other if people don't bring questions. For those exams, you're allowed to bring a sheet of notes front and back. That is because I designed problems to not just be look it up definition based, but you will actually need to know whatever is on that sheet to be able to answer those questions. So as part of that studying, you'll generate some questions and those would be great questions to bring to that day before the exam study session. I think that's just about everything. Questions or concerns before we dive back into our linked list? All right. We haven't implemented update, and we should probably do that. So I went back and made a final decision on exactly how I want to do this remove, and I ended up just factoring it all into the loop, took out the try catch. I think it was good to show the try catch for how that call would be used, how we would catch an exception that was coming back from that. But I ended up just doing this. I can describe it in more detail if people want, but this will be what I reveal once you get into doing this for yourself. I feel like this will be plenty clear. I just made a previous node, and rather than finding it and then using the find node before, we're just going to assign the previous to be the current, move the current onto current.next, continue to do that. Well, we haven't found the element that we're searching for in the list, and we're not at the end of the list. So this will continue to search and search and search and search. If current.next becomes null, then we haven't found it. Because we also got in here that says that it's not the tail. And after the tail is null, so we should return false. Question?
Do you want us to update our code to be that, or do you care if you just leave it?
Doesn't matter how, whatever you use for your code. This is the code that will be revealed as a file on Canvas for you to use for that assignment, but there is nothing that will tie you to this exact syntax for this file.
Well, is that for remove back to element?
Yeah. All right, so first thing to do today, we're going to write the update. I think we should probably also write the toString. couple pieces of information that we can write. Eventually, we'll need to make an iterator constructor for it, but we'll come back to that once we make more progress on the iterator. So we've done all of this. I'm going to keep this private method below everything that we are working on. So we're going to start the update, which is somewhere. Here. All right, so our update, as we said it, we're going to make sure the public can access this. It's something that you're going to want to be able to do from outside the scope of this. It's going to return whether or not the update was successful. It takes the index we want to make a change at, and it takes the element we want to replace the current value with. It's going to throw, we said, update's going to throw an illegal argument exception and a null pointer exception. I'm just going to steal these while I have them. First thing we want to do is check for these exceptions. So we could do something like, what's something that could go wrong?
Element is null.
Element is null. If that is the case, what message should we give and what exception should we throw?
Null pointer exception.
Yeah. We can throw a new pointer exception with some text. What should that text say? Yeah. What else can go wrong? Quite a bit can go wrong here. We have quite a few conditions to write.
If the index was less than greater than the size.
Yeah, we've seen this a few times now. If the index is either less than 0 or what, greater than or equal to in this case.
Greater than or equal.
Greater than or equal to, yeah, replacing. We're not adding a new node that could be positioned after everything that is currently in the list. We're making an update that says that we need the index to be an already legal value. So this can go up to, but not including size, because as soon as you have size, that is the index that is after the last element that's in the list. So if it is greater than or equal to the size, then we have an issue. What else can go wrong?
Plus is empty.
Yeah, this could be empty. So if we try to call update at all and the list is empty, there is going to be no legal bounds, but that might be something else that the user wants to know. So we can just call this empty. We're going to call this. This is where an index out of bounds exception would make a little bit more sense, because this is more. It's not that the argument passed was illegal. It's that there's a misunderstanding with the list. I honestly wouldn't hate an illegal argument exception here. And since we haven't declared it, we're just going to copy it. So we have two different possible ways to throw this exception now. That is fine. Get a different message based on that. Of course, if we wanted this message to have any chance of showing up, we probably want to do this before we check index and size, because if size is 0, index is greater than or equal to size is gonna catch that. So we would never see list is empty. We would only ever see past an index is out of bounds. Now we're overriding, if the list is empty, the user's gonna see list is empty. Any others? I think this is everything we need to consider. Is there a special case for an update? The head? What happens, what do we need to consider if we're trying to update the head? You don't need to find it, you have direct access to it. So we can just say, if index is 0, we can just right away set head.data to the element. Because we have that direct access and that node's data. We look back at our node is protected. We are still within this package, so we can access it. What else do we have immediate access to? Tail. So if we're trying to do the tail, that seems like something we can reasonably just check. If index is, do you want to call this size or do you want to, yeah, let's just call it size. We can call it size. That's 1. Because again, if we're checking for size, that is out of bounds. So we can just set the tails data element. Should probably be an else if. What's the generic case? What do we have to do?
Use find node before and.
Yeah.
Next for that.
Yeah, since the user is passing in the index where they want to update it, we've already done the logic for this, so we can just call find node before. Find node before returns the actual node itself, so we need to make a placeholder or a place for a new name for an existing node. Something like this. The node before, the node that we want to change is going to be the previous node to the one we want to change, but we are going to want to make a change to that next pointer. So we're going to save that off and do exactly that. How do we successfully do this? What line should we write? Yeah?
We're trying to change the element of the next node. correct?
Yeah, the node past previous.
So when you do previous dot next dot data equals element.
I like it. In any of these cases, we're going to return true. Is there an easy way to factor this out? Because there is an else, there is no path through this entire block without doing something. We have to have hit one of these blocks. And if we do anything in any of these blocks, we want to return true. So I think we can say regardless of what we did here, we can return true. This is useful because if we return in some other way, be an exception, the way that you can write this in a Boolean is basically if update, you then make the try and it now has to return true in order for you to get into whatever block of code that you write. So even though there's no return false anywhere, this is still useful to do. Anyone who does this can now surround it with logic that says, if this was successful, then move on. And you don't have to necessarily return false in order for it to not have returned true, which it would do in an exception case. Okay. I think this is update. And I've been very bad at including my at overrides. So I'm gonna go make a quick pass for that. There's an override. There's an override. That one I got, this one I missed.
What happens if you don't remember that override?
Doesn't have a compilation error, but this does tell the, you can see now how this red squiggly has gone away, saying you don't need to implement anything else from this list.
Yeah,
The add override is a very easy way to communicate that I am attempting to override one of these methods. And now you can check the number of at overrides versus the number of required methods in your interface.
okay, thank you.
Good questions? Mostly clarity. Okay, what else? I think we're basically done now with the exception of the toString and the iterator. Let's go ahead and write the toString, because I think being able to visualize what this list looks like is going to be important. So we're going to override the generic toString. This is what this always looks like until you eventually return it. Whenever you write a toString, I generally like to start with just an empty string. So let's go ahead and make that string. I really like to use S. You can use whatever you want. Here, doesn't particularly matter. Initialize it to be the empty string. This just says there's nothing there. Yeah. We could use a string builder. I find just using concatenation is usually enough. So string builders absolutely do work. You can feel free to use them. I tend to just use concatenation whenever I do it. So now we can say we're going to start at the head of the list and we want to go node by node. For each of those nodes, we want to do something with its data value. And then we want some kind of separator between that and the next node to come. But we have to fence post this so that we don't have that extra separator at the end. It looks pretty bad if you print a list of numbers that is 1 through 5 and you end up with something like 1, 2, 3, 4, 5 with an extra comma at the end. And an easy way to fix that would be, all right, there's no comma at the end, but there's a comma at the beginning. And none of these are correct. You want to make sure that the commas are between things, or if it's a list, usually you want to display a list through square brackets. This will communicate to the end user that this is an actual list and those associated elements. So let's think about how we actually want to utilize this. We don't even want to start doing something if the list is empty. The list is just not going to have anything, but maybe we still want those brackets. So maybe we can start, instead of with the empty string, we'll just start with that bracket character. What do we do next? We can check if the size is greater than 0. Follow method. If size is greater than 0, then we can go into that loop. We know that the head at that point is a node with a value. So we can make that assumption that the first thing to print is that value. So what would this loop condition look like? Maybe we need some kind of counting variable, something that's going to help us with this, or we could phrase it just based on the node itself. What appeals to people? Yeah.
You could do. The way I've seen it done before is you make like a node that goes through the list, and then that node is not next, is not null. You just print the things.
Okay, let's do that. We could make a singly linked node T that we're going to call current, and we'll set that to be the head. So we have a new name for the head node at the moment. So now we can say something like, well, the next node is not null. What do we want to do inside the loop if we do this? You probably have to. You have to add to our string something about the current node but we will eventually want to move to the next node, but there's still something that we want to do with that first node's value. Yeah. Actually, never mind. I'm saying you need to forget, but. Yeah, we do have the ability to access the data directly because we said it's protected. And we know that cur is going to be the node that we're looking at and we don't yet have the data for. Yeah.
We want to store the data that's in cur into our S.
Yeah, so we could say we're going to append to S something that is now in string form. How are we going to get something about this node? Because it's generic. It's not an integer. It's not a string already itself. So how are we going to access some way of printing whatever this happens to be? We could do cur.data. So what if that is an object? Two-string. Every object has a two-string. Yeah, so we want to make sure cur.data.toString is going to give us the string representation of whatever that happens to be. If it is an integer, it'll just print the integer based on the integer class in Java's toString. If it is an object that is something that you've written or something that someone else has written, all of those objects have a toString. Yes.
To be clear, the two string that we just decoded is not the one.
Correct. This is the toString for whatever this node type happens to be, whatever this T happens to be, that's that data field. This could be a person object. And in this world, all that matters about a person is their name, their age, and their salary. And if we looked at this class, we would actually see a toString that goes through the fields and prints the fields, their name, their age, and their salary. And now we would be using that as a way of printing the value of this node because this is a list of person objects. If this is a list of integers, now we're using the integers toString. Whatever this T happens to be, there is a toString for it. We're going to be invoking that toString that we did not write. Yeah.
Say you had well, I guess, never mind, because you run into an immediate problem with the null, but say you had a list where one of the elements that wasn't the end element was null, but you still wanted to iterate through the list, how would you check that?
You'd be checking the next reference because now null would actually get printed. When you try to toString an element that has a null, that toString should handle that case. If this object is null, then it will print null.
No.
That is a great point. That should not be the case in our list. If we are making a list of something, we checked that everything that we tried to add to this was not already null. Otherwise, we threw an exception. Right? If we look at our lists add methods, whenever we pass something, we check whether that something is null and we throw an exception. So in this list, it is impossible to store something where T is null. The T object is null, yeah.
There could be a case where you want to have a null object in the list, somewhere like in the middle.
Yeah, quite possibly. In that case, you would need, in this list, a default value that represents null to check for. Or you would actually want to allow them to do it and not throw this null pointer exception and not write all of this. But then you would have to check and make sure that none of your other logic is assuming that none of this is null, because as soon as you try to dereference null, now, oops, you've crashed your whole program because we can't continue. So this is a design decision on my part. We don't have to check for it. We don't have to worry about it as long as we don't allow it. And then we have to be consistent about not allowing it. All right, so everything clear about this cur.data.toString, what that is representing? The string representation of whatever type of object we are storing in this list, whatever the T happens to be. That has a definition of how to print itself. Great. In fact, we could probably even throw in a comma there. we're going to check. Because as long as we're in this list, the next is not null, which means when we break out of this list, the next is null. When we break out of this, there's still a print to do. And it's the last print that we don't want to append a comma to. So that's why this is an intelligent setup that allows us to actually do that. Or does it? What do we think? Is this gonna go through the last time and print the last element with a comma? Or are we intelligently skipping the last one and have to handle it later? Yeah,
Doesn't that end up with an extra comma?
what happens when we're at the tail? We're at the tail, next is null. So we've already handled the previous node, we looped back around. We've set cur equals cur dot next. Let's actually write that to make sure that we're doing it. In preparation of the next pass. We're at the tail, cur dot next is null. We haven't done anything with the tail,
I would skip out, I would skip out of that one.
yes. Any other thoughts? Does that work? Yeah,
Yeah, that works, because then you can, once outside of the loop, print per dot data, with the
Yeah.
last bracket.
Yeah. yep. So after we fall out of this, we know we've reached the end of the list except for that very last node. So we can append to S, just since we now know that cur is the tail, we can say cur dot data dot toString without the comma. Although we can add the very end bracket. This is also happening once. I will think though that since this is inside of that if, that is also what we want to do at the end here. So rather, we're gonna break out of the if and do it here. Why do in 2 lines what you can do in 1? And now if this if is false, we can see that all that is printed or is returned as part of this toString is just the open and close brackets. So now we actually get the effective empty list print that we want when this list is empty. Once we're done with this, we just return S. And now we have a happy method that does what it's supposed to do. Questions on this toString? Yeah.
What about the two string, but should we be coming into that add over?
Probably should. Since it's not defined immediately in the. In this list. The add override says that it's being overridden, which is true, it is being overridden higher up than that, but it still should be there. Yeah,
So this is assuming that any object in our list has a two string.
yes,
I think there is not two string in that object.
you get a default toString. There is a default toString for lots of objects that just print the addresses of all fields unless it's a primitive type, and then you'll get, it looks very strange. But
we don't need to catch it.
right, we do not need to catch anything. All objects have a toString or a toString that is provided for you. If you were to get an issue here that would tell you that this was an object that you created, and you should probably go write a toString for it. If at least that's not what you're anticipating. Yeah,
CC override is optional. Do you ever docker some fits for not including it?
I really only care about compilation concerns, unless there is an outcome that specifically states something like. Make sure this is documented to a particular industry standard that we have defined in class.
Would they stop us for not using that override?
That's a good question that I don't really answer to. As someone who's not actually created the ape,
That's
that'd
fair.
be a good question either for Tony or for people who have actually gone through. So any of the 8 study sessions that we will be hosting, I think we have 3 of them in the 2 weeks before the 8th. I think the plan is currently the Friday, that's exactly 2 weeks before, and then the Monday and Friday, that is the week before the 8th. There's not a plan for something the week of the 8th. Overrides are supposed to be below, is that?
Like you're asking like in below for like levels. Is that what we're
I've always ever done it right the line before.
No, there's portions of your code below where you're at. where you're-
Yeah. Makes sense. Yeah,
So it's like not handwritten, but like looked over by an instructor. And
Yes.
Say you forget to do, like you have all of that, like you forget to do the 2 strings, like I assume they would like.
so Tony's method, to the best of my knowledge, I'm supposed to be the backup who helps. He has never requested this. We auto grade every question and then we manually go through anyone who gets between so you need a 75% to pass. Anyone who gets higher than a 65%, we manually review the answers to each one of those questions to make sure that shouldn't have, how much understanding is there? Should we pass you based on what you have provided? So we do manually go over anyone who is close.
So if you get like a 74.7, like you guys would be.
Probably, we would find a reason to get you over the hurdle,
Okay,
probably.
I had a dream about that last night. It was like.
It's not supposed to be evil, it's supposed to be kind of a baseline, we're gonna maximize that pass rate. All right, so here's our 2 string. I think we will implement any other further small things that we need as we find the need to. So I think we're gonna quickly go back to our iterator and make some progress on this. So we talked about an iterator last time. The entire purpose of this is to be able to modify the list while we are iterating over it. So we want to be able to add and remove while we are saying something like, what are all the nodes in this? As we identify an even integer, remove it. As we identify an odd integer, add another one before it. Something like that. We want to be able to change the list while we are saying this node is part of it, this node is part of it, this node is part of it. And the indices for this get off a bit. As you try to add something or you try to remove something, it is not apparent what the next node we should look at is. And the purpose of the iterator is to make it obvious what is the next node to go look at once we do an add or remove. So because of this, we're going to want to make sure that we implement all of those. Since it implements iterator, we can see that we need 4 methods that we talked about. We need a next, a has next, an add, and a remove. Okay, so for our iterator, the first thing we want to make sure is we have a constructor. This constructor is good. We are going to have the current node that we are looking at. We are going to have the previous node to the one that we are currently looking at, and we need to instantiate the list because we're no longer in the list class. The list is now going to be an object that an iterator is composed of. What is the current list that we are iterating over with this iterator? We are going to pass in the list. So when we instantiate the iterator, we call an iterator, we construct an iterator to iterate over a particular list. That list is known at construction time. Great. Why don't we think we set pause to be the head? Any thoughts on why this might be null? Yeah.
The list passed in, that's like size. Oh, can you have a list size 0 and still pass it in?
Yeah, you should at least be able to make an iterator over a list of size 0.
Yeah, well, I mean, yeah, in that case, it might not happen, right?
But I think the default that we made in our constructor for this is that we set head to be, not add, where's our actual constructor? Head is null. So if we set it to be head and head was null, then we would effectively be setting it to be null. I think this will become apparent as we start realizing how these work. And the reason that is, we'll see. So has next is going to be the easiest one to write, so we're going to go ahead and do it. I'll do this first so that I don't forget. We want to make a has next. Has next is public. It returns yes or no. It has a next node that we can look at. So it has next for the moment. Takes no parameters. And the purpose of this is to determine whether there is a next node to look at. How are we going to do this? We're going to check the value of the current node. So we can say if pause is null, then we want to set it to be the head. Because the only time this is going to be null is for the head. So when we actually start trying to identify the next node, calling has next before next is going to set us to call the next. If this is a brand new list, the way to do this is to make the next node that we're going to go look at be the head. So if pause is null, we set the current position we are looking at to be the head. And since we made head protected, we have direct access to the list's head. Because we are in that same package. Otherwise, we would have to write a getter for it. We have direct access. Otherwise, what is the next node that we would want to look at? We would want to look at wherever we are, it's going to have a next. So we want to move to the next element. The current position that is the position that we would want to do next is going to be the next of the current one. Pause dot next. This is not right. Has next is not returning this or doing this. This is what next wants to do. Sorry, we want to return from here. We're actually going to store this off because we're going to want this in a second. We actually, sorry, want to return whether the head was null. That makes way more sense. Similarly, here, we want to makes way more sense. So in an empty list case, we want to return whether or not the head is null. Otherwise, if pause has a value, then we want to check whether the next is empty or not. So it has next now returns yes or no, whether there is a next node to access. Next is where we're going to do a lot of this work. So next itself is going to return the value of the next that it sees. So it's going to return a t and still take nothing. Basically, the goal now is we assume that has next has been run. And now we can move to the next node. We don't want to run next without having called has next, because that has next is going to be the protection of is the next node null. If it's not null, then we can move to it. Yeah. Because they all have to operate on this particular list. There's no further information we need in order to determine is there a next node to iterate to, because it's all inherent in the structure of the list that is a part of this object. Very good question. All right, so within next, we're first going to check as next. So if as next returns false, then there's an issue. We're actually going to throw an exception in this case. the kind of exception we can throw. Is a no such element exception. This exists and is not a frequently used exception type. But it's very good for that. And do we want to say anything with this exception? All right, now we're free to actually implement this. So to move to the next node. What is the first thing we think we should do? Yeah,
I have a question about
Yeah.
as next. Would we not want to make it not equal to null? So that if it returned true, then it'd be saying that. The next element isn't null.
I like this, and it's actually true. You're absolutely right. So if we return whether the head is null, then has next returns true if there's no node, if there's a null node, which is the exact opposite of what we want. So I think you're right. We do want this to return not equal to null. Excellent point. All right, now I think this is correct. Looking at this, what should we first do? We have two nodes here. We have the current position and we have the previous position. So when we call next, the first thing we can do is set the previous to be the current in preparation for moving the current to the next one. So we can set the current. The current value of the current becomes the current value of the previous. Now we again need to check something about pause. If pause is null, something needs to happen. That's true. So if pause is null at this point, then we need to set it to be the head. Now that we've successfully shifted the position of what we are looking at, we're going to return the data of that new node. And this will be useful if we are iterating and we want to do something with that return value, like print it out. If we're iterating and trying to print the list, if we're iterating and trying to, it's also a great debugging tool to make sure that you've advanced correctly to the next node. So next is going to move our position in the list to the next element. This should do it. Now let's start thinking about remove. In the middle of this iteration, we're going to try to remove the node we're currently at. How is this going to work? And what needs to change? So not much needs to happen. We don't need to return a Boolean with this remove because the goal of this iterator is to make it impossible to remove something that doesn't have a value. We need to has next prepare ourselves, next set us up with the next node. When we do a remove, we need to prepare that next to point at the correct node. So we've written that next already to point to that next node. So this remove is just going to use a single exception to indicate the possible failure that it has. And it's going to throw in a legal state exception. Inside of remove, we first need to check for this exception. So this exception is going to happen either if the current node that we're looking at is null. Or if the data at that node is somehow null. Those would be the two ways that we can't actually remove successfully, or we don't want to try to remove. So if pos is null. Or if pos.data is null. Then we can't actually remove, we will. If we pass this if statement, we will actually be able to do this. So the first thing we should check as a side case is whether we're trying to remove the head. So if this is the case, then pos is going to be null. Because that was the only time it was going to be null was before we set it to be the head. If we're trying to remove the head, then that would be exactly how we'd identify that. So let's say if we're currently pointed at the head and we want to remove the head, we can straight up call the lists remove now. Because the list is implemented, we don't have to redefine how any of this is done. We just have to worry about, in particular cases, which remove should we be calling. So if we want to remove the head, if the current position, when we call remove, we're looking at the head. We just want to remove the head. We know how to remove the head. We just call list.remove, passing it an index. That index is 0. If we're not trying to remove the head, then we actually have the work to do of attaching everything. So we can actually do that ourselves. We can say pre.next is going to be set to be pos.next. This just takes the next reference from the node before the one we want and redirects it exactly as our remove did. When we do this, since we're going around the list methods, we need to make sure we decrement the size. If we call a remove, the remove handles that for us. But it's easier here than just calling the remove because we know everything about, we're already at where we need to be. We don't need to pass an index and go find it again. So it's easier to just re-implement a small piece of the list remove rather than trying to reinvent the entire wheel or call it and have it do all of that work. You could do either one of those though. Once we are done with all of this, it's important now to, once we've removed it, what is the node? Because now we need to move to the next to do this. What is the node that we want to be looking at? Before we can remove again, we need to call next. And this is a feature that's inherent within iterators. If you add or remove, you're not immediately pointed to the next node. You need to call next first to identify which node that you're going to be at. So you can't remove from an iterator and then remove again. You have to remove, next, remove. So we actually want to point it at the node before the next node that we might want to look at. So we want to point it at the previous. So we're going to set, once we've been successful, we're going to say pos. It's going to get to be the previous node such that when we go call next, we're going to advance it. This is everything from the remove. And it's annoying because we're exactly out of time. We have just an add and a couple of pieces to tie together. within the iterator and the actual linked list. So we're gonna finish this off and test it tomorrow, making sure everything works, and I will finally reveal the assignment that you have at this point, a little more than a week to work on. Because we'll actually have the work done that we need to use as a baseline.
Question remove, would we need to worry about reassigning the tail if it was,
We tried to remove the exact tail,
yeah,
possibly, so, yeah, we said. Previous.next equals pause.next, tail has not been reassigned, if that is the case. I think we might be right, we need to worry about. Cause it would call this, and within this, that's what's one thing we're not caring about, I think you actually might be right, and there might be a bug in this.
chill and work on.
No, it wasn't. Yeah, that's great. It's, are you? Yeah, that's one of the. Yeah. It's hard.
Not yet.
Can I?
Great.
That's summaries.
Yeah.
Thanks.
When is the